Gulf of Mexico. Beneath these waters lies some of the world's richest natural gas fields. Now, an ambitious plan is underway to harvest that energy from the ground. It's called the Independence Project. The goal? Drill wells and lay pipeline to get the natural gas to a central processing platform and then to shore where it's sold. Natural gas networks have been around for a long time.
Okay, coming down.
But no project's ever been attempted in waters this deep. For years, thousands of underwater wells have lined the shallow waters of the Gulf of Mexico. They supply 20% of the natural gas to cook and heat homes in the United States. But the demand continues to grow, and the wells in the Gulf are already working at capacity. Energy companies have long known that gas reserves existed in the Gulf's deep water. But the technology didn't exist to drill here, beyond the continental shelf and 9,000 feet down until now. It's the most daring effort yet in the race for more energy from the deep sea. A team of mega machines has been hard at work for months, building a vast deep sea gas network. They have 5 main challenges. Drill 15 wells through nearly 2 miles of water and almost 3 miles of sea floor in an 1,800 square mile gas field. Lay pipeline connecting each well to a central processing platform. Install cables along the pipeline so that engineers on the platform can control the flow of gas from each well. Drive massive pilings to anchor the central processing platform to the ocean floor. And finally, build a huge pipeline to deliver the gas from the processing platform 135 miles to land. Construction on the processing platform is underway here in Ingleside, Texas. Once it's installed in the open ocean, this platform will be the hub of the network, purifying the natural gas and sending it back to shore. But first, there's a gas network to build. Enter the Mega Movers. The Deepwater Millennium will tackle the first job, drilling the wells. Next, the Lorelei will build a network of pipelines to connect the wells to the central platform. The Toisa Perseus will run control cables along the pipeline. And only one ship can tackle the next step, building the monster pipeline to the shoreline. The Solitaire. Installing the huge anchor pilings is the job of the Boulder. Meanwhile, another team of mega machines constructs the massive gas processing platform. The platform is as big as a city block. In order to float above the gas fields in the Gulf, it must be attached to this huge 4-towered hull, which is en route to the Gulf atop an amazing ship, the mighty Servant 3. Mounting the huge platform on the hull will be one of the heaviest lifts ever. That's when the crane-like heavy lift device will swing into action. To get the network up and running, each of these machines will have to do its job perfectly. But Mother Nature can wreak havoc on even the best laid plans. The Gulf of Mexico is notorious for powerful storms, and summer is peak hurricane season. 7 major storms made 2005 the worst hurricane season on record and the most devastating in memory. This year could be even worse. The first job is getting the gas wells up and running. Months ago, the Deepwater Millennium drilled wells for this project. the ship's drill pipe reached 9,000 feet down to the sea floor and dug in. Then it punched through another 3 miles of sea floor to reach pockets of natural gas, an incredible 5 miles below the water surface. Now, the Deepwater Millennium will answer the $2 billion question. Will enough gas flow freely to make this well worth tapping? To test the gas flow, the ship must gently lower this delicate column of valves and sensors to the bottom of the well. The Millennium is perfectly designed for the job. She's a drill ship. At 726 feet, she stretches longer than 2 football fields. A huge tower on her deck called a derrick will lift the column and lower it into the water through a hole in the middle of the ship. The column will descend to the well through this pipe, almost 9,000 feet of steel tubing that stretches from the ocean surface all the way to the top of the well. Once the testing equipment is installed in the well, engineers on the ship can determine if natural gas is flowing freely. The Millennium's crew prepares to lower the testing column into the well pipe.
You might be able to bump it out some more, Jason.
It takes a delicate touch.
Is it all the way up?
If the column smacks into anything, it could damage the critical seals that keep gas in and water out.
Right, watch your fingers, Harley. There's a bunch of places you can get bit.
The crew lines up the column at the top of the well pipe and begins to lower it.
I got buttons there. Oh!
But suddenly, it stops descending. A jammed column could mean costly delays.
If we change that assembly out, then you're probably looking at 10 to 12 hours.
Get ready to tell him to stop. If we start stroking his lock, man, I don't want him to stop. Stop! Stop!
The crew examines the column to figure out what's gone wrong. It refuses to budge. They try to gently wiggle the test column.
That's it. Look, what you gotta do is you gotta push it that way.
Starting now.
You wanna watch this lock mandrel?
There it goes. We got it.
That does the trick.
All right, that's good.
And the column finally slides into place.
There it goes. You wanna verify that in the book?
It'll take 2 days for the testing equipment to reach its destination.
Put it up!
2 days before the crew can answer the critical question: will a well drilled in the deepest water yet actually work? The Deepwater Millennium hovers above a gas well in the Gulf of Mexico. After several setbacks and delays, the crew gets the sign they've been waiting for. The testing equipment has reached the well, 9,000 feet down. It's time to see if this well can produce for the Deep Sea Independence Project. With the touch of a computer screen, engineers open the valves deep inside the well, and gas begins to flow. The crew monitors every sensor and valve. The test is a success. Gas is flowing freely from the well. The Millennium has successfully gotten 15 wells up and running. Now, it's time for step 2 of the Independence Project: laying the pipeline that will connect each well to the processing platform. It'll take a vast network of pipes laid precisely on the sea floor. Now, a new mega mover takes charge. The All Seas Lorelei is a pipeline building pro. At 600 feet, she's longer than the Washington Monument is tall. A massive pipe manufacturing facility fills nearly 2/3 of her hull. Off her stern, a 200-foot guide called a stinger lowers the pipeline to the sea floor. Creating the network of pipelines is like building a city sewer system nearly 2 miles below the ocean's surface. The lower lay's biggest challenge is laying each of the pipelines on their predefined pathways. Deviate even a few inches and it will be a massive tangle of steel. The lower lay has just a few months to complete the pipelines before the gas processing platform arrives. And summer is prime time for hurricanes. She's got to lay this pipe before bad weather catches up to her. Below her decks is a massive hold with over 22,000 pounds of steel pipes. The pipes can't be welded at the bottom of the ocean. That happens here in a high-tech assembly process called the firing line. Massive elevators lift 40-foot sections from the hold and slide them into the firing line. The pipes seen here will form a single pipeline 45 miles long. Amazingly, even steel pipe over an inch thick bends like a garden hose under its own weight. 12,000 feet, over 2 miles of pipe are suspended between the ship and the sea floor in a giant curve. The lower lay will work around the clock to spit out up to 3 miles of pipeline every day, making her one of the fastest pipe-laying vessels in the world. With the wells and pipeline construction underway, it's time for step 3 in the Independence Project. Laying the cables that will control each well's gas flow. It's a job for the Toisa Perseus. She's one of the only vessels that can install these cables in such deep water. Her huge reels hold miles of the thick cables. And her aft deck is bigger than 3 basketball courts. It needs to be. That's where the Perseus carries its giant cable connectors. The crew places a connector next to each well, and then runs the cable along the pipeline all the way back to the processing hub. These cables are an essential part of the network. By supplying the electronic and hydraulic power to open and close the well's valves, they'll allow an engineer on the processing platform to control the flow of gas from a well as much as 45 miles away. The first step is to carefully spin the cable out of the hole. Below deck, this massive reel holds the longest control cable of the project. 13 miles long, weighing 1,200 tons, the weight of 700 automobiles. The end of the cable is threaded into a curved guide to prevent kinking the delicate internal elements. A tricky maneuver that requires handing off the cable between 2 cranes. Safely in the guide, it's lowered to the deck. The crew attaches a stabbing pin to the end of the control cable. Now, they must lock the pin into the connector already installed on the sea floor. It's like putting a plug into a socket, except that the cord is nearly 2 miles long. 2 huge tensioners close in on the cable. Their tractor-like grip holds the entire weight of the cable as it's lowered. It's a straight shot through a hole in the middle of the ship, 9,000 feet down. There, the real challenge begins. Plugging the pin into the bucket-sized socket. Once the cable is in the water, there's no turning back.
Okay, coming down. Okay, coming down.
After a 4-hour journey, the moment of truth is at hand.
The stab point for us.
The cable lowers to the sea floor a dozen feet from the connector. ROVs, remotely operated vehicles, are the engineers' eyes and hands on the sea floor. They're launched from the ship at the start of every underwater operation. Without them, engineers can't plug in the control cable.
Stuart, do you happen to see that mud mat in front of you there?
The crew steers the Toisa Perseus and the plug dangling far below, closer to the metal structure. If it hits and they damage the high-tech plug, this multi-million-dollar cable will be nothing but junk on the bottom of the sea.
Ready to try and stab this?
Inserting the stabbing pin at the end of the cable into the small socket on the connector is a real challenge.
I'm Snow, and just like you, the further in the winter we go, the heavier I get. And while your pants struggle to support the heavier you, your roof struggles to support the heavier me. And your cut rate insurance might not pay for this, so get Allstate. You can save money and be better protected from mayhem, like me.
Mayhem is everywhere, so get an Allstate agent.
It's like making a perfect dunk shot from an airplane flying at 9,000 feet. For the Perseus and the entire team of mega movers, one technology gives them the critical ability to stay exactly on target. Dynamic positioning. Computers measure every factor affecting the ship's position and control the engines to hover in one spot, move forward or backward, or even sideways.
Fly it over the stab point for us.
On the bridge of the Perseus, the crew relies on an ROV, a remotely operated vehicle, to guide the stabbing pin toward her target.
Then it clockwise 90.
It's in, but something's wrong. It won't lock.
Oh, and just put it on the swivel plate and tried to push the swivel plate around.
The stabbing pin is turned out of position, and there's nothing the ROV can do to turn it back. Without a perfect connection, this cable will be useless.
BLS bridge, come
The
up
crew
1 meter,
comes up
please.
with a clever strategy. They enter a new heading for the Perseus, and as the ship rotates, it swivels the cable, turning the stabbing pin on its axis.
Okay, we put a meter of slack in it.
The plan works.
Yeah, roger, I'll stop on it.
The pin finally locks into the socket.
Okay, can you follow it over and just watch the touchdown for me?
With the hardest part of the mission accomplished, the Perseus can now lay the miles of cable that will control the flow of gas from the well. The Mega Movers have tackled 3 out of 5 major parts of the Independence project. They've tested the 15 wells, laid 210 miles of pipes to bring the gas to the processing platform, and installed control cables throughout the network. A major step remains: building the giant pipeline to get the gas to shore. It will take almost 20,000 pipes and months of work to construct the 135-mile Independence Trail. And there's only one ship in the world strong enough to build it, the All-Seas Solitaire. She's got to lay this huge pipeline before the processing hub can pump gas. Few vessels would dare to attempt this mission, but the Solitaire's not just any ship. She's the largest pipe-laying vessel in the world. At 1,200 feet, the Eiffel Tower could easily lay on her deck. A pipe welding assembly line runs the entire length of the ship, and a huge stinger juts from her stern to guide the pipeline to the sea floor. Like the Lorelei, the other pipe-laying ship on the project, the Solitaire builds the pipeline in one continuous motion, welding the pipes together inside her hull, then depositing the finished pipeline on the sea floor. But unlike the other ship, she does it on a much, much bigger scale. The Solitaire's 6 cavernous holds carry over 21,000 tons of pipe. That's more than the weight of 120 jumbo jets. Even this many pipes doesn't last long. Solitaire can lay 4 miles of pipe in a day. Huge barges constantly replenish the supply of pipes to keep this mega pipe layer busy. And that's where the ship's cranes swing into action. They're built for speed. Most cranes have a single long boom. These monsters have 2 arms, giving them amazing accuracy and speed. To complete the Independence project on schedule, the Solitaire has to build and lay the pipeline fast. First, the crew mills the pipe's ends to provide a smooth, clean surface. Then, the pipe is welded together at 8 welding stations. Each weld adds more strength to the joint. A special drone even welds the seam inside the huge pipe. Completing this pipeline will take over 21,000 welds. When every station is ready, a bell rings, and the pipe seems to move out the back of the ship and into the sea. But that's not what really happens. Miles of pipe on the sea floor connect directly to the ship like a massive anchor. Huge tensioners like tractor treads squeeze the pipe to hold it or let it out. When the pipe moves through the firing line and then into the sea, it's really the ship that creeps forward on the new pipeline growing in her belly. The Solitaire works around the clock to complete the pipeline on schedule. This is the deepest pipeline she's ever laid. But her biggest challenge is still ahead. Installing a massive T-assembly, a connector that will allow future pipelines to link to the Independence Trail. Welding the large spigot-shaped T into the pipeline shouldn't be hard. The difficulty will come in trying to push the bulky structure out of an assembly line designed for pipes. The crew has a plan, but it's risky. 135 miles away on the Texas coast, work reaches a fever pitch on the final part of the project, the Independence Hub. This huge floating platform will process all the gas from the project's 15 deep-sea wells and send it 135 miles to shore along the Independence Trail. Soon, this mega structure will be towed out to the gas field, but first they have to finish building it. The hub is made up of 2 parts, the upper unit or processing platform, and the lower unit, a hull that will keep the hub afloat. The massive platform will process 1 billion cubic feet of natural gas each day, enough for the cooking and heating needs of 5 million U.S. households. When it's done, it will be the heart of the largest gas processing project in the Gulf and the deepest anchored platform in the world. But first, the team needs to join the upper and lower units together. Just outside the harbor, another mega mover arrives, the mighty Servant 3. On her back, the massive flotation hull, the 4-towered structure on which the platform will rest. The mighty Servant has brought the hull all the way from Singapore where it was built, an incredible 10,000-mile journey. Now she has to offload her cargo, and she does it in a very unusual way. Huge ballast tanks inside will slowly flood, letting the ship settle 2 stories lower in the water. Then, the tugs will pull the hull free. It's a simple but dangerous process. Both the ship and its cargo can quickly become unstable. And the huge towers of the hull can catch the wind like sails. In a strong gust, the hull could sway, crushing anything in its path. Conditions have to be perfect, but today, that's not what Mother Nature has in mind. Out in the Gulf of Mexico, the Solitaire is about to tackle a critical part of the Independence Gas Project. The ship's already laid miles of pipeline called the Independence Trail to bring processed gas to shore. Now it has to install a massive T so that future pipelines can hook up to the Independence Trail. First, the crew must weld the T into the pipeline, but there's a problem. The joint between the pipeline and the T has to be lined up perfectly, and the tool used to align the joint is jammed inside the T, bringing the entire operation to a screeching halt. While the rest of this massive factory waits, engineers scramble to free the alignment tool.
Since you can't pull it by hand, we're going to put a winch on it, pull it on through. Let's bust that one around that one like that.
A chain hoist and manpower does the trick. The Solitaire is in business again, and the T moves down the firing line. Now is when the operation gets dangerous. As the pipeline exits the Solitaire's hull, 3 powerful clamps called tensioners bear its weight. They hold the massive strain of nearly 2 miles of pipeline hanging between the ship and the sea floor. But to let the huge T pass, each tensioner or clamp has to be opened one at a time. And all the weight of the pipeline, 655 tons, is shifted to only 2 tensioners. If one fails now, hundreds of feet of pipe will whiplash through the ship on its way to the sea floor. The Solitaire starts to move the T through the firing line. The first of 3 tensioners opens. All eyes watch as the T inches forward. The other 2 tensioners strain under the load, but they hold. Twice more, 1 tensioner opens, and the entire strain of the pipeline is held by the other 2. Finally, the T is on the other side of the tensioners on its way to the sea floor. It's a major success for the Solitaire, bringing the ship one step closer to building the pipeline on schedule. On the Texas coast, the huge gas processing platform and the hull that will float it must be joined together. But first, the team has to get the hull off this ship, the mighty Servant 3. This mega cargo ship offloads by sinking, letting her cargo float. For the last few hours, a strong breeze has made it too dangerous to move the hull, but finally, the wind has died down. Now the tricky business of sinking the mighty Servant 3 begins. The hull's massive towers jut up like 4 huge sails. Every time the wind kicks up, the massive structure strains against the mooring lines with tons of force. On the bridge of the mighty Serpent, the captain carefully controls the flooding of ballast tanks.
Snow. And just like you, the further in the winter we go, the heavier I get. And while your pants struggle to support the heavier you, your roof struggles to support the heavier me. And your cut rate insurance might not pay for this, so get Allstate. You can save money and be better protected from mayhem, like me.
Mayhem is everywhere, so get an Allstate agent. Are you in demand?
Over the next 10 hours, his ship slowly sinks into the harbor. Finally, after a globe-crossing journey from Singapore, the hull is afloat. Now it's time for a mind-boggling lift. The gas processing platform is as big as a city block and weighs almost 9,000 tons. The crew will have to hoist it 200 feet into the air and strategically lower it onto the hull's support pillars. It's like lifting a 500-foot warship. There's only one machine for the job, this heavy lift device, or HLD. It's one of the largest of its kind in the world. The first step is to slide the topsides along this skidway and onto this barge. It'll take 2 huge winches and a little lubrication.
These men in the white overalls are applying the grease on top of the Teflon skidway. We call it pumpkin wax. It's kind of pumpkin colored, but it's gooey, it's sticky. And my wife says every time I walk by it, it attaches itself to me.
The winches turn, and the 7-story platform begins to move. At the water's edge, the process gets trickier. Water in the barge's ballast tanks has to be carefully adjusted to accept the massive weight. It takes 8 hours, but finally the platform is on the barge. Tugboats wrestle the platform into position underneath the HLD. And the crew attaches huge A-frames to lift it. But high winds kick up again. In these conditions, lining up the hull perfectly under the platform will be almost impossible.
We need to make sure that the hull is in the appropriate position when we stab down, because we only have a 3-inch tolerance when we stab down, and that hull has to be in a perfect position.
For now, the operation is on hold, but it won't slow down another mega mover. Out in the Gulf, preparations for the hub's final home are underway. Keeping the enormous Independence hub secure in the Gulf's stormy seas will require heavy-duty anchors and a special ship to install them. Meet the Boulder. The columns of her pontoon-like hull make her incredibly stable, essential for lifting the huge anchors which will secure the hub to the ocean floor. With her massive open deck, she looks more like a platform than a ship. If the Boulder doesn't install the anchors perfectly, the Independence hub could pull free. That's what happened to this hub. Thunder Horse was the biggest hub in the Gulf until Hurricane Dennis ripped it from its moorings. To make sure this doesn't happen to the Independence hub, engineers are installing 12 permanent anchors called suction pilings. A 2.5-mile-long cable will connect each piling to the floating hub. The Balder's challenge: place each piling at exactly the right spot and perfectly level nearly 2 miles down. If she succeeds, these will be the deepest pilings ever installed. She'll need her cranes, some of the most powerful afloat, to pull it off. Together they can lift 7,000 tons. But it's not just about brute strength. It's also about precision. The Balder's 7 engines help keep the ship right on target. And staying in position is the name of the game, especially when you're installing pilings this big. Each weighs over 200 tons, as much as 5 tractor-trailer rigs. They're each 88 feet long and 18 feet in diameter. Securing them is a process that takes perfect coordination of the cranes, the engines, the winch, the remotely operated vehicle, and the crew on deck. Barges bring the pilings to the ship. Cranes lift them on board and set them down very gently. The crew attaches a harness and chains for the lift. It's a very big and very dangerous maneuver, requiring the biggest shackle on board. The crew checks every inch of the shackle. Even the slightest flaw could lead to disaster.
What he's doing, he's looking for microscopic cracks in the surface of this shackle that might grow to a critical size when it's highly loaded during lift. If that were to happen, the shackle could fracture and we could have a real disaster on our hands.
The 2 cranes lift the piling to turn it on end. It goes without a hitch, and the piling lowers over the side of the Balder. On the bridge, the crew monitors every movement. If the Balder isn't level, or if she begins rocking, the huge piling could become a wrecking ball, crashing into the deck or punching a hole in the ship. With all that weight over one side of the ship, you'd think it could tip over. But back on the bridge, the crew controls ballast tanks in the Balder's hull to counteract the weight. The piling lowers into the sea. Then, in a blast of escaping air, it's on its way. A 4-hour journey nearly 2 miles into the depths. The huge anchor has to be placed within a hair's breadth of a buoy set on the ocean floor and set at the right angle. Wind isn't a problem, but currents are, and the Balder's engines strain to steady the ship. If the piling isn't installed perfectly, the massive tension of a 2.5-mile mooring line could rip it apart. The piling hangs just feet from the ocean floor. What the crew must do now is truly incredible. It's like being on top of a skyscraper and trying to put a nail on the end of a string on a certain spot on the sidewalk. ROVs, remotely operated vehicles, are the eyes of the project engineers, allowing them to inch the massive piling closer to its target. The crew will have to get it just right if the pilings are to be ready when the Independence hub arrives. The Balder moves closer to the target, ready to install one of a dozen pilings which will anchor the Independence hub at the center of the gas field. They go for it. The 200-ton piling stabs into the sea floor.
Does anybody have a visual on draft readings?
The piling's weight drives it an incredible 45 feet down. It's in the right place, but is it aligned properly?
Our orientation is very good. Probably about the best we've achieved thus far. Very good.
Tightest one we've had.
Hey guys, I was looking.
The ROV moves in for step 2. It closes the valves that seal the end of the piling. Then it connects a powerful pump. As the pump sucks out the water inside the piling, the structure sinks even deeper into the sea floor. Mission accomplished, but the Boulder's crew doesn't have time to celebrate. They'll work around the clock to install the remaining 3 pilings before the hub arrives. Construction of the Independence project is almost complete. The 15 wells, 220 miles of pipeline, 120 miles of control cables, and 12 mooring pilings are nearly ready for the Independence hub's arrival. In Texas, it's countdown to the big lift, the last obstacle facing the project engineers. Hoisting the nearly 9,000-ton processing platform onto the 4 towers of its behemoth flotation hull. It's a job for one of the biggest lifters in the world, the Heavy Lift Device, or HLD. But it's never attempted a load this large. Inside the control shack, engineers continuously monitor the HLD's controls in preparation for the big lift. The mammoth booms are 500 feet long, and 23 miles of cable weighing 900 tons run through her motors and winches. Sensors on the booms and the cables provide constant feedback to the engineers. On the hub and the barge, the crew performs their final checks. Then, all but a few crew members move off to a safe distance. A broken cable now would send the mammoth platform crashing to the ground. The lift's motors begin to turn. The cables take up the enormous weight. Then, an ear-splitting boom gets everyone's attention. A fitting for the A-frame has adjusted under the strain. The lift continues. Cables strain as the HLD takes the full weight of the platform. Then, suddenly, one side is free. In the control room, every sensor is double-checked. The motors and winches turn, and the nearly 9,000-ton platform hangs free. But the biggest challenge is still to come. Setting the suspended platform on the 4 points of its flotation hull. First, the platform has to be raised even higher to make room for the hull. Then, 4 tugs work in concert to turn the hull and push it into place. On top of the hull, an alignment pin will be the guide to make perfect contact. The hull has to be positioned precisely for the pin to fit inside a 24-inch diameter guide.
10 feet height from the guide to the...
Now, it's up to the team leader to thread this needle and mate the platform to the hull.
When yours line up, if you get there.
Thick steel mooring cables connect the hull to shore. They'll control the critical position of the hull underneath the platform. The team leader communicates constantly with his spotters on the hull's towers.
I'll put you in the guide.
Put a swing. Easy boom up with a easy swing.
He directs the massive platform to come down.
A twist, but
With only 3 inches of tolerance, it has to be perfect.
Yeah, 10-4. I don't need quite a foot to get in the guide, but that'll still work.
But the alignment is off.
It's turned just a hair.
If they continue, the stabbing pin will hit one side of the guide, and the platform will miss its connecting points.
A little more, Terry, done. All right, right there, stop.
The team leader calls for the mooring cables to be adjusted.
All right, Larry, booming down on the south.
The platform eases down even more. One side makes contact.
Moving the north down.
But there's a problem.
How about you back there, JJ?
The other 3 corners aren't matching up.
How much more you need? All right, flying back and forth right there.
Master Royce, yeah.
Master Royce.
We're booming down with the north boom to take the twist out of the module.
Engineers in the control shack lower one of the HLD's booms by a few feet. The platform inches down even further. The 4 corners of the platform line up perfectly with the towers of the hall.
He's right on the money this time.
They've done it. The Independence hub is complete. It's a landmark moment in the most ambitious deep-sea construction project ever attempted. Soon, the team will tow the hub into the Gulf and link it to the vast network of wells, pipes, and cables. It's the jewel in the crown of the world's deepest natural gas network. Within a year, the Independence hub will deliver 1 billion cubic feet of gas each day, thanks to a team of amazing mega machines.